some of the sector which is true, and then upcoming technologies. And now there is no manufacturing of the display in this country. But I don't know whether you know that at one time India was the leading manufacturer of the display. The younger generation, they may not be knowing, but the displays were getting manufactured very near to this place in Ghaziabad. In Central. Not only Central, there was a combination of Central, Hotstar, the Videocon, and product manufactured in India was going in developed country in Japan, Korea, who are the leader today for the display manufacturing in Europe or many other countries. Unfortunately, the companies who were manufacturing the display, they could not succeed further because the time wants change. There was a pressure to thin down the thickness of the funnel, that picture tubes. Then the very fast technology change came into the force, then plasma display, LCD, and then OLED, what we are talking, then the micro LED, and then quantum display is a journey. I will not go in very detail in the technology, that may be very heavy, but it's a journey we have gone through. And the main reason was for the country who was leading the display in India, it was looking very good when the product manufacturing here is going to the around the world, and it was written that made in India. One of the person who was who has started with the black and white picture tube and was leading the plant of the electron gun for the black and white picture tube as well as the color picture tube, Arvind is here. Unfortunately, he is still building the plant of the displays, but not in this country, in China and Korea, and the technology which is on it. Actually, someday we will request him to speak in this platform. It's good to see you, Arvind. We were colleagues at one time in the Central. I'll go with the journey. We had the relationship of the customer and the supplier when he joined the applied material, and I came in Mozambique to set up the solar factories, and even Tata. And again that some kind of relationship, and today with this platform we are meeting after a long time here. And thank you for being here. We start the journey. I don't know how many of you have joined the last session, because this is I think the fourth or fifth session of the SID here. Can you please raise the hand? So still many few people. So I'll go, I have structured the presentation and I'll give the brief overview of the center, basically what is happening in the center, because some new people here, maybe a little faster than the facility, and like ma'am was explaining the TFTs, we fabricate the TFTs in this country, so we are working on those TFTs. And then I will come to the flexible and printable electronics, which is the topic Ashwini has chosen for me today. Okay. Then I'll touch upon the emerging application, and then you can ask the questions. So this is the center. This center was announced in July 2015 when this government came first term in 2014, and the discussion was, I think, the similar which is happening for the displays today for the semicon, which one of our friends from the meeting was explaining the reason why the application is not approved for the display. The discussion was that yes, there should be a semicon fab in this country, but we all know that semicon fab takes a lot of money, so it was taking time to be ready for the country to have the semicon fab. And again, the reason that technology is not existing or does not exist in this country, so technology has to come from somewhere. So then there is a team of experts there. The discussion happened at a very high level that what is next than this conventional electronics, which is the flexible electronics, which we will see very soon, which we see in the cars and everything. Then the decision has been made, there should be a National Center for Flexible Electronics. The center was made, and the center is fully flexible. The center is supported by the Ministry of Electronics and Information Technology, and the center has a mandate to work. You see the two blocks, academic ecosystem, we have a very strong academic ecosystem. Even we are producing the manpower for whole world. People are getting trained here and serving somewhere else, so we have a very good academic system, so there is no debate on that. Then there is a good industrial ecosystem also, but most of the industrial ecosystem, they are dependent on the technology which is developed outside, because the industry wants to make the money in the time frame of the 2 to 3 years. So the technology which are getting developed in the academic ecosystem to reach to the industrial ecosystem, somebody has to work in that era. Okay, the wide gap, which is the value of the gap, more of the technology dies here. So this concept came out that to have the National Center for Flexible Electronics, who is serving in this area, taking the knowledge, converting to proof of concept and giving to the industry at a stage like they are buying the technology from outside. So in this center, I think it's a 6,000 square meter center, and then what is there basically, there is, you will find that all the equipment set, including the pilot production line in the academic area, which you will see very rarely, which is happening in this center. The focus area in the centers are, you see the 6 blocks, 1 more blocks has been added after the first phase that I will basically talk later. First is TFT. So this is thin film transistor. We are printing the transistors. Okay. So at this stage, it is going to the defense area, mainly to serve the DRDO or ISRO, very specialized area, because you don't get the technology from outside. The second block, you see the fourth all that. And when we talk on the technological platform, when we go in detail, we proudly say that IIT Kanpur is the only place where the fabrication of the TFT. Yes. So then the OLED, I'll give you the history of the OLED. This one we have the facility, full facility of the OLED. Not only the R&D facility, but the cluster tool where you can make the 4-inch by 4-inch OLED. Okay. And before going to that one, maybe you all were talking, I was thinking that I will show you later. Today I asked one of my friends to bring one of the OLED which is manufactured in this country. So this is the OLED which everybody was talking about. I think that some connection is losing picture. Okay. So you can see the brightness and everything which you are talking about. But I can tell you one thing, that we are saying that yes, the LCD is ruling. That is true. But you see the 2024 data of the mobile phone. Earlier the phone having the OLED screen used to be very expensive. In 2024, the OLED screens have surpassed the LCD screen in the phone. Most likely 2025 and or 2026, you will see most of the phone are having the OLED screens. So what it says that it is very economic when you go to the lower form factor. When you are going to the larger form factor, it is still expensive. Okay, that's the reason that you see in the large form factor, the TVs and everything are very expensive. Or in the car, basically it seems to be expensive, it's not expensive. The problem is the supply chain is not there. See, everything what is coming for the auto sector, it is coming from outside. You take it any display, whether it is LCD display or OLED display. LCD display, the full ecosystem is developed. OLED display, the full ecosystem is not developed. Okay. LCD, like you were explaining, that you need a TFT backplane. Here is a self-emissive display. Only thing they're driving and everything that, auto industry, because it's a cycle of 5 to 7 years when the car comes on the road for the reliability factor. So you see the cycle, it will come into the cycle.
There is only one shortcoming that for the blue color, it has a less lifetime as compared to the red level. but maybe it's
But that is a theory. The thing is, we have developed a OLED for one of the, I would say, the most luxurious car. I cannot disclose here. Where the problem is solved, you will see that display is coming in the luxurious car, which is the OLED. Okay. But it is a small prototype. So I will just. Oh, sorry. And the third is the organic photovoltaic. That is the photovoltaic on the paper. There is special technology. Then the fourth is sensors. We are constrained to develop the sensor for the healthcare sector mainly. And then materials, because you need material. Nobody is going to give the material to develop all those things. And the printed batteries. Okay. So we have started the journey to develop this technology by the conventional route, but our mandate or our target is to do everything by printing route to lower the cost of the manufacturing. And to join them together, that we need a system integration group. Basically, we have one system integration group who are integrating all the components like phone needs display, phone needs TFT, phone needs every component. So somebody has to join together to make a device. And below is the sectors which we target to serve. But the OLED, which is the topic for today, there is one dedicated facility which is called Central Center for Display Technology, and that's what I was talking about. This company who was manufacturing the picture tube at that time, yes, so they have given the money to the IIT Kanpur to build a center where the OLED facility was set up in 2005. The technology which is coming now. And that facility is having the lithography, the TFT backplane, the OLED fabrication, integration and testing. That means everything. So you can take the bare glass or the other substrate and come out with the display. Doing the TFT part itself also, backplane also. So this facility still runs. Okay. And one of the person is sitting here, he was very much involved. We were in the center at that time. Okay, this still runs, this facility is 20 years. And if you see this is another very new center which I was talking about, which came out in 2015. Here you will see all the equipment from lab scale to the production scale, which is the printing technologies. You name any technology and you think any equipment in the world, you will find in this center. So there is 80 crores of equipments are in this center to have from lab to fab. You can say that that's the reason we say one-stop solution of printable electronics. So it's a 6-floor centers, a lot of things. Basically, if you have the time, visit there and you will really enjoy to see that center.
it's also in Kanpur.
It's Kanpur. Okay. Now coming to the topic, which everybody that he has given the topic that flexible electronics automotive. See the car, one of the example, and tell me where is the place left where the electronics is not there. You see from front to end, and not everything is written here. This is the one of the snapshot from one of the analysts. They developed the report. You take it from the starting from the front to the back. Everywhere you will find the electronics and role of the more flexible electronics. The reason that electronics is done with the different routes, because you cannot print the electronics by conformal method. You need to have the method where you can either print or make a hybrid as a conformal surface. That is the reason if you go to even the back, when you have an antenna of your car, most of this one, that is as the antenna, but you can very well print if you have a technology to print conformal surface. Okay. You go inside the car, everybody says, you all was saying, we were discussing that everywhere is a display in the car. Everywhere. Okay. Display will not run, standalone. You need electronics to run that display. So if you are having lot many displacement means you have lot many interfaces. When you have lot many interfaces, that means you will be having lot many wires which is going here and there, connectors and everything. Think about that durability, reliability, where the flexible electronics will play the role. Okay. If you see the beautiful car for inside, having a lot of display, the moment you open the dashboard, see the what is backside in that after the dashboard. You will see bunch of wires going here and there. Nobody will like it because you like the displays. So that is the reality. So that's the role basically the flexible electronics, I would say the in-mode electronics is going to play, because the car's era of the displays going to be built in the car. You see in the front side, you see in the back side of the seat, you see the handle of the seat, you see the pillar. Even you will see the feature of the high-end car where you are sitting in the back seat, you want to read everything. When you see like this, what is the speed, what is the temperature, which we call the silent displays or the transparent displays. So everything is coming there. How they will run? They will run. You need electronics also to run those displays. Okay. So that's the potential of the flexible electronics or printable electronics. How basically this when we say the printable electronics, what are the essential things which is needed? You need a substrate, you need a material, and then you need equipment. Equipment could be the skin printing, the flexo, gravio, inkjet, whatever the technology you are going to print, or for the TFT, basically you need slow die or some kind of technology. You process them, and then you will see the beautiful application of flexible electronics. Whether it is going in the display or going in the various application, it depends, but that is the infrastructure you need. And you can think about that, if you can develop the technology by printing root, how simple it is going to be. First thing, the $1 billion fab will become the $1 million fab, where everybody is struggling. That our friend was saying that there are applications, but those are not approved because of XYZ reason. So some of us are in the committees from XYZ reason. There are many reasons. And one of the problem reason is the technology is not in the country. Okay. And other reason is because it's very expensive. If he's setting up the fab, if the OLED fab is getting set up, we need billions of dollars. So when you need that kind of money, then definitely the person who is investing the money will think whether he is able to compete with the fabs which is already running in other countries. So there is a lot of if and but. If you have a technology where you can reduce the cost, then definitely that not many companies will take the chance. That's what the printable electronics or printable displays, the whole world is working now. Now, coming to the automotive sector, I'll basically discuss in a very limited manner. This is one of the technology which is probably going to change the era of in-mode electronics. So the equipment is developed, which is the plasma jet printing. It is developed by the company called Space Foundry. We and Space Foundry are working together to develop the in-mode electronics. Space Foundry is the incubated company of NASA, and at IIT Kanpur we brought this lab-made equipment, and we started making or printing the conducting line. You think if we can print by roll to roll, or you have the plasma jet, a kind of print head you mount on the let's say a arm, then you can print in the your behind the dashboard also. So all the wire which you see with the low current wire, you can just replace by this printing. That's what you are going to see. If you see let's say, let me give you the example. Basically, I would say the big brand of the coffee machine, which has a very sleek panel. Okay, coffee machine is a coffee machine, whether you are basically touching the touch panel or you are just pressing the button, but that's very expensive, because behind that you see basically all the in modern electronics. So all home appliances, what you are going to see, it is going to change. The aviation industry, when any accident happen, the fire is because of the fuel and the wires. So the Airbus and other companies, they are printing on the doors, basically most of the wire, they want to take it out. Okay, so these things are happening. There was challenges region basically that is very difficult to print the conducting line on the conformal surface. You need a technology where you can say the direct write, means if you are having the ink and converting into the printing, you do not need any dryer in between. So that means it's a plasma jet which is basically converting in the, you can see the solid metallic iron impinging on the surface and just making the conducting line. So that's this technology which is coming up for the printable electronics. Now coming to the display, you know, the first OLED, it was announced or developed by the Kodak in 1987. 1996, we have seen in the stereo of the Pioneer that our car, there was the OLED, which was the dot matrix. Okay, the 2003, the first commercial active material OLED product was rolled out, and 2005, which was I'm talking, the OLED program was mounted by the Samtel, DST and IIT in India, and 2006, this was developed in this country. The thing is, the fab is not here, so that it didn't go to the manufacturing fabs. Okay, and there was the reason, this is what we were talking about. And now you see in the left hand side from the stereo to the what is going to be. We were just talking that maybe the next year we will see the foldable Apple phone. Think about that, what is going to the cost. Maybe the year after you will see the rollable phone, because the display which is going to be like, you can make this we are making the display, this is a glass, very thin glass, you can say the 0.8 millimeter or 0.7 millimeter or 6 millimeter glass, but you can make the display on the polyamide film, plastic film, which is 25 micron or 40 micron, and that what is happening, and that demonstration also happened in the SIE. Okay, so very soon you are going to see the rollable phone or rollable TV. Earlier, at our when we started, watching or learning the displays, display was meaning was TV, television. That was the display. Now that sector is basically not growing that fast, but the other sector, everyone you want to have the display everywhere. Even when think about that, when we were studying in the science lab, we were having voltmeter, ammeter. We used to see the needle and the read analog. Now there also people want the display, the digits. At your inverter, you want to read the voltage and current, and you want to have the display. Everywhere is the display. Home appliance, everywhere is the display. So display, there is no limit. That it's just that's what is happening. So very soon you will see the rollable TV, rollable. I think in fact the rollable TV is already in the market. Very expensive. So I can again just share one thing, that first plasma TV which we have bought just to analyze, that was approximately I think 8 or 10 lakhs at that time. We just bought in the sample to open it just to see what is inside. So that's every technology started from that point of view, and then you will see slowly the costing coming down. Now what actually our effort in the display is having the printed electronics together. Right now the display, most of the display you see, it is the evaporation routes. That's the reason you have to produce in volume to sell at the price what you are buying in the market. Okay. The second thing is the partially printed, because we have the liberty, we have the two centers. One is having the Samtel Center for Display Technology, having the vacuum technology, and then printing center, which is NC Flexi. The ultimate is everybody is trying the fully printed displays. So if you can print fully, let's say last flexible display, that means everywhere you can put the display. Very soon you will see the displays or maybe the some of the product you might have seen on as a label on the product. The product is speaking itself, basically having the display into that one. So that is also coming. Which means the smart packaging, you will start seeing the displays. So that's a new market, a very big market. Maybe very soon you might have, you will see the announcement also, very big companies coming forward in this country having the flexible displays in the packaging. So that's what everybody is trying to have those displays. Some of the example, this you all know that one. I'll skip this. I have shown you this one. This is developed here, but this is given to some company. They are testing it in the two-wheeler cycle. Okay. Now printed display. Actually again what happened? You have everything in this country. Problem is the material. What you are talking about, that's a material problem. That's not the basically technology or the printing problem.
Same thing likewise, we don't have.
Absolutely. So the OLED, the major work which need to be done in this country on the material. But the good thing is that 2-3 companies started doing in the material. And very recently, I think the IMET has also taken that challenge to work on the material. So something will definitely happen. If you have the material, then ink formulation, process, dye optimization, that is easy to tackle. It's not that easy to make the stack because you have to make maybe 15-20 layers to make that display, but even you can do that one. The challenge remain if you do not have the good material, the lifetime of the displays. Okay, and that's the problem in the blue. What you are talking about, the man. It's not the price no more. That's the challenge, and that I think that for some displays it is okay, but some, like if you want to have a display, for example, in the front side of the car or inside the car, there is no problem. If you want to have the display, for example, where the regulation comes, let's say the tail lamp of the which the cars are there where they started using the OLED tail lamps, okay, the high-end cars, okay. There, fortunately, they use the red color in the tail lamp, so that is okay. That's what is happening. This is the transparent displays, which is also made here in this facility, and you can see that you can say that you can see the display from both the sides. You see whatever you want to see. This is the tail lamp. These are OLED made, which you started seeing the cars, high-end cars. It is also coming, and then a lot of things inside the car. Where high-end car, you see all the lights basically, which is the OLED made, like because they are very thin, sleek. They looks beautiful. This is another thing that the digit. So many things are made with the digits. Lot of every day the India is consuming billions of LEDs. Everything is coming from outside because we are not manufacturing the LEDs. We are assembling the LEDs. We have the SMT machines. We are just assembling the LEDs. We do not have the LEDs here. So what is tried out here to make the digit by OLED. This is made with OLED by printing tool. So the cost is same. The idea is that in place of one LED, you can print number of LEDs and you can make that any display what you want to make the display. So that's good thing. This is something to think about that. This is made on plastic, this display, which probably you will see very soon in the market, that in the consumer electronics or in number of applications. And think about that from where the power is coming for this display. Display need the power. If you see the bottle here, So back side of the display, there is a printed battery there. So the battery is also printed there. So that's the technology which you are going to see in the near future. You have, it's a part of printable electronics and the printable batteries in back side of these displays. So thank you very much. I think this is enough for today. You may, if you have any questions, feel free to ask. And I didn't go to the technology, it may be too heavy for this session, but you may ask any question if you follow. This is the EFT. So we have certain steps, basically this is in the so this size we can make the full back plane and display, so usually lithography process or something like that. But you may visit if I need something like that. Thank you very much for the question. Asmani, over to you.
Thank you so much, sir. That was really insightful and gave us a very good perspective as to how much innovation is happening in India. And for the next session, I would like to call Mr. Satyadeep, Advanced Application Engineer from 3M.
Yeah, good evening all. First of all, thank you SID and ICA for providing this opportunity to talk about auto electronic stuff. Yeah. So I think when I listened to Dr. Srini from Mahindra and when I listened to Dr. Sudhir sir, so I think when Srini sir projected a BOM of automotive display, so we see almost 6 to 7 line items there. And we know typical automotive display, the thickness is hardly 8 to 9 mm. Probably the curved ones are much lesser. And some of the curiosity comes how all these 6 to 8 or line items are kept inside. We cannot use any kind of fasteners there to lock in. So that's where the usage of adhesives come, where everything is bonded in this world. So when I took Dr. Sudhir sir, so he told behind the display you see a number of FPCs because the thickness of FPC is very thin. So the modern world, as FPCs again being connected using some kind of connectors or interconnects today. So the next world of connecting is by using conductive PSA, electrically conductive PSA. So already people are using to bond FPCs using electrically conductive PSAs and the job is done. So it has been typically bonded by using a 30 micron tape. So that's how it is getting evolved. So typically this is my content which I am going to take in the coming session. And majority of the time I will be discussing about the design challenges in automotive electronics and how it is being addressed by material innovations. So yeah. So I think we had learned the evolution of automotive electronics. Nothing major to talk about this, but let me start with an interesting fact. A premium car which we see on road typically consists of 70 to 110 electronically controlled units, and which is programmed with greater than 100 million lines of code. And in comparison, the Boeing Dreamliner 787, it is being coded with 14 million lines of code. So that's how auto electronics is more sophisticated and software designed. So that is one thing. And we know the evaluation and in today's car scenario or vehicle scenario, a typical car, auto electronics estimates for about 40% of total new car cost in 2025. The same was around 18% in early 2000, and the same thing was 5 to 10% in 1970s and 80s. So the evolution of auto electronics is enormous. So that's what I would like to tell. So auto electronics is the major driving force for mega trends as seen in this slide. We all discussed in multiple sessions before the vehicle safety and autonomous driving, where even a simple feature like lane assist or park assist system to completely autonomous self-driving vehicles, everything is associated with auto electronics. There is a complex system, software, high-end microprocessors which are working behind, and that's how the job is getting done. And especially when I talk about autonomous driving, so there are array of sensors, radar, lidar, camera, and microprocessors coming into picture, where complex real-time data is taken and critical decisions are made over safety. So we understand the complexity here. And similarly, every car is connected, every vehicle is connected. So it might be connected vehicle to vehicle, vehicle to infrastructure, or vehicle to cloud. But how it has been done through complex data, high-speed data processing, and complex and robust complex communication modules, as well as cyber security. So auto electronics coming into picture, and similarly with the EV advancement from ICE to electric vehicles, and which is commendable. So power electronics is being used for battery management system, vehicle control units, and motor control, and what all. So the major thing which I want to communicate here is the auto electronics is developing very fast than predicted, and there are a number of design challenges which has to be addressed. So we know the automotive world, how harsh it is, and the testing requirements of automotive world, it is very harsh again. So and again, all the OEMs or tier 1s are generally targeting about optimizing the weight, including electronics coming into picture. If I talk about electric vehicle, majority of the weight contributed by electronics again, apart from the body in weight or structural thing. So how this has been addressed is again by going into more compact packaging designs and FPCs, and multi-material bonding comes into picture here. So most of the places where metal were being used, now high-end plastics with advanced fillers are being used. And the challenge here is how to bond these plastics to metal. So we have traditional epoxies, we have traditional silicons or acrylics which we can do. But the thing is, so when it comes to plastics, low surface energy plastics are coming into picture. And again, we know typical automotive testing which they do at 10G, 15G vibration and nothing should come out. So in those scenarios, dissimilar material bonding is very much coming into picture, which has been addressed by toughened structural adhesives, toughened structural 2K polyurethanes and 2K acrylics. So this is the latest innovations, and especially for low surface energy bonding, this is one of the key critical innovation in adhesives platform. And similarly, we know each and every electronics, when PCB coming into picture, we know thermal or thermal management is very much important, and especially with more and more complex packaging designs, removing huge amount of heat in a short span is challenge. And again, when we talk about LEDs, momentary heat is being developed in microseconds, and if it is not removed, so then there is a degradation in overall lighting. So thermal tapes, thermal tapes of higher conductivity values, greater dielectric strength, as well as electric vehicles, the demand is everything should be UL flammable rating, and everything should have IPC ratings. So have been developed with aluminum nitride, boron nitride fillers, and graphene based upon particular form distribution. And so when electronics is coming into picture, so one of the major problems is electromagnetic interference and EMI EMC compatibility. As all the electronics present in a PCB are interconnected, each SMD device might be operating with its own frequencies, and there should not be any crosstalk between these two devices, and especially when it being utilized in ADAS systems where real-time data is being captured and a small loss in data leads to huge disaster. So that's how EMI EMC picture comes into picture, where specialized EMI shielders are being used. Apart from EMI shielders, absorbers are being developed. So we typically call it as FFDM, flux field directional materials. So which is new innovations and constantly being used, and high-end ferrite cores. so to observe and shield the noise being generated. So these are the few innovations with respect to EMI EMC. And when it comes to overall reliability and durability, we know automotive testing how critical it is, vibration resistant, high temperature resistance, drop resistance. So for all these things, so the development of structural adhesives plays a vital role, and even the bonding tapes. So for example, I think probably you would have seen this slide in a different manner in previous presentations. A single car with all auto electronics applications. So in this, I would like to showcase you two applications, exploded view of two applications. How well the requirement has been addressed by advanced materials. So this is the exploded view of a radar, especially with the perspective of bonding and other functionality. And I would like to see talk more about camera sensor encapsulant, camera lens bonding and structural adhesives. So camera lens barrel is made up of PCABS plastic or plastic. It can be low surface tension plastics, and lens we know. So both are having different quotient of thermal expansion. And this is the one of the important requirement is the bonding line should be very much thinner, thin bonding lines. And realignment is very much important when it comes to camera lens assembly. So camera lens along with image sensor. So how it has been bonded. So here the innovation comes with development of structural adhesives, which is having a dual cure mechanism. So it can be UV cured for faster processing and handling strength, and the secondary cure happens to thermal, or it can be room temperature cure. So this is one of the innovation and the market demands, because even a small, and we know whenever there is autofocus is being required, the camera lens keep on moving. So in the cases, the minor vibration has to be observed. So there you can see the quick recovery foams coming into picture with good vibration absorption and damping properties. And similarly, as we know, the camera is continuously capturing outside data, and the entire unit is mounted on automotive bumpers, which is subjected to a lot of vibrations. But still, though no vibration should transmit inside these kind of systems. So there we have the slow recovery foams coming into picture. So similarly, for all these different applications, different requirements, so the design challenges are different, and similarly the solutions catered for each and everything, so it's different. So preserving image quality is very much important, because if it is not done, so blurring or loss of resolution and image jitter and instability or distortion artifacts comes into picture. So especially when these are the major information providers for ADAS ECU, and which keep on collecting the real world data. So maintaining a proper bond strength as well as the application requirements is important. So this is the anatomy of radar performance. So, and again, similar to camera, radar is again collecting continuously the real-time data by producing the radio waves, and which is hitting on the object and coming back. The time and distance has been calculated. So the major requirements or challenges encountered is complex EM electromagnetic environment. Again, where we are addressing using our EMI absorbers and shielders. So there are performance degradation of RF components, because of which there are certain problems of frequency drift or signal to noise ratio being increased, and so which can be addressed by introducing our thermal solutions. It can be in form of tapes, it can be in form of thermal pads. So thermals comes in different forms: thermal pads, thermal tapes, thermal gel. So the major objective is to remove the heat and maintain and reduce the hotspots developed at the interface. And when you talk about radar or camera or anything related to ADAS, so we typically OEM gives a warranty. So it's 10 years or it can be 15 years, and till that nothing should impact it. So reliability and lifespan of electronic components is coming into picture. So where accelerated aging or solder joint fatigue or material degradation can be common causes of failure modes. So there where we have to address it on a very priority basis. And safety criticality, safety features cannot be compromised leading to dangerous situation. As I told, it is very much related to RAS. And cost of warranty, any kind of thermal failures leading to costly warranty claims or recalls from the OEM, and obviously it damages the reputation of OEMs. So robust thermal design is always crucial for any kind of electronic components. So that is what I meant to say. Yeah. And you are able to see the EMI observers being placed. It can be on the RF components. So where the noise being generated by these kind of systems has to be kept low. So because maintaining sensor integrity and accuracy is very much important, as well as like regulatory compliance is also coming into picture. So considering all these factors, I think advanced material functions is very much important. So if I narrow down to the recent innovations and emerging innovations with respect to material solutions going into PCB or electronics, so we can, as I already explained you, thermally conductive adhesives for EV batteries and power electronics. So people are coming with high temperature resistance thermally conductive adhesives with silicon, advanced silicon resin as a backbone. And so we have dual cure and multi cure adhesives for speed and precision, where the curing mechanisms will be 2 or 3. It can be UV cure, moisture cure, or heat cure mechanisms. And toughened adhesives are being developed, where black rubber-based copolymers are being introduced in acrylic resin or being introduced in polyurethane resin. So where we get strength as well as elongation. So with these kind of toughened adhesives. And as we were talking about displays in the morning, so obviously in order to prevent yellowing of displays over a period of time based upon the weathering, so we have these optically clear adhesives as well as LOCA being developed with lesser haze and higher light transmittance. So this is one of the new things. And smart and functional adhesives are being developed when we are bonding two substrates using the using the adhesive. And if there is any degradation in the adhesive, so as it is being exposed to atmosphere, it absorbs the temperature from atmosphere and it self heals. So the crack being generated. So this is one of the new trends. And debond on demand solutions, especially as OEMs are considered about sustainability coming into picture. So they want to reuse the material or recycle the material. So we know structural adhesives, they impart a typical strength of 22 to 25 MPa strength. So I cannot literally separate it. So if I do separation, obviously I will end up damaging the components. So in those cases, we have debond on demand solutions, where I can debond the bond created using electric impulse or heat. So that's how I am able to reduce, remove the adhesive and reuse the parts. So these are few of the electronic material innovation solutions which is going on in the market, and people are again considering adhesives with integrated sensors. So whenever so this is one of the new topics which is emerging and which people are working on it. So especially when there is increase in temperature at the bond line, or when there is more stress coming into picture in the bond line. So these sensors will indicate the bond line is subjected to so and so extreme conditions. So it has to. So we will have an indication. We have to reduce that. So these are the advancements which are there. And overall, to conclude, I think the evolution of automotive electronics driven by EVs, ADAS, and autonomy hinges on advanced materials, and moreover, adhesives are critical enablers. So without adhesives, I think when the world is making a transition, so they play a very vital role. And I would like to say it's no longer a glue; it's a precision material science. Yeah. Thank you.
Thank you, Satyajit. That was really insightful, and it is great to see how the progression of the agenda has taken place. In the first sessions, we talked about manufacturing, how this represents a very, very big opportunity for India to capitalize at the moment. And then moving on from there, we have covered basically the technical knowledge that India has that we can exploit to reach to that level of manufacturing that we foresee. And now we're talking about innovation with 3M. And moving on to the next speaker, I'd like to introduce Mr. Karthik Raj, who is the technical architect from VESA SRMT.
Good evening to everyone. Thank you for having us here. So, myself, Karthik Raj from Assam Technologies, and thank you, Ashwini ji, for having us here, and thanks to SAG as well. So far in the session, we have seen a lot of things, a lot of topics. Most of the things are related to the hardware, manufacturing, and how the display technology has evolved over the years. So from SRM side, we would like to talk about the software side, software aspects of the display, particularly towards the safety and security status. So I will be talking about the functional safety as well as the functional security, particularly the ISO 26262 and 21424 standards. So this standard is being published. It is said to be published. Probably will happen sometime around September. So this is done by an organization called VESA. So we are working alongside VESA. VESA is an organization in US. They are responsible for publishing different standards for displays. I think you guys might have seen the desktop monitors when you try to purchase online. You might see some badging from VESA, like this is adaptive sync certified or display SDR certified. So VESA now joining into the automotive world. So they are coming up with the standards for display in automotives as well. So this is a modern render of the modern cars. So we have so many displays. We try to wrap everything in a single picture here. Here we have there are a lot of displays. We have info center infotainment displays. We have lower info displays which can act as a reverse parking display as well. And there is a rear entertainment to the left and right. And there are certain critical displays here. For example, the side mirror display that you are seeing, the top left, and there is a right side mirror as well. So this is one scenario where so you can see this is more like a zoom in version of that side mirror. So right now in the car we have traditional mirrors which act as a side mirrors. So there is a technology where that can be replaced with a camera sensor, and there is a camera sensor in the right, and to the left there is a display. So that will replace the actual mirrors. So that display can display the right side and left side view. So and there is then to the right you see another use case where we have a collision alerts when we do a reverse parking, or there is a sensor and we display some critical information in the display. So ideally in any display where we display or where we show any critical information like collision alerts, like speedometer, tachometers, parking sensors, should meet a safety standards and security standards. So this standard is not for the entire car; it's only for the displays that's being used in the automobiles. So this is we were there last week along with the 3G in the US display week. These are some display trends that was displayed in last month. So you can see the left hand side there's a pillar to pillar display, and right hand side you can see heads up displays with the transparent displays, and the bottom left you can see headset displays, and this is another pillar to pillar displays. So you can see a lot of critical information being displayed here. So all this information has to be protected. Yeah. So talking about the safety which we speak is like we have a ECU and we have a display. The information that we send from the ECU to display has to be safe and it should be secure. So this in US and Europe they have a very strict security standards. So the upcoming cars should meet a certain safety levels, including every component in the car. So display is one of the key components. We should also meet the certain security standards. So any new standard that is being put to the open world will, particularly in automotive, will take a lot of time. So unless we have a standard way that every OEM can follow, it's difficult to accommodate or adapt any standards. So yeah, this standard covers like how we transfer the information from the ECU to the displays. There are different protocols that we follow, like some algorithms like the CRC algorithms, cycle redundancy checks, and we also have some standards to detect the frame losses. Let's say we are turning on the left-hand indicators, and the side display will be on. That will show us the side view. And let's say there's a hardware fault and screen freezes. So we should have some technology or some algorithm to detect those frame losses. In case there are any freeze in the frame, those should also be detected. This algorithm will have some basic encryption and some CRCs that can help us to detect this frame loss and frame loss. So this is one cluster where we have a lot of all the critical information left and right side of the cluster, and the speedometer, tachometers, and everything. So one thing is to protect the entire frame. The second thing is we should also protect all these yellow boxes. These boxes are basically we call it as a region of interest. So in addition to secure or making the entire frame safe or secure, it is also necessary to ensure these regions of interest also being secure and safe. So these are the standards or the security compliant policies that different regions like Europe, even one criteria is followed, and that's a separate standard for USA and separate standard for Asia, like Chinese, Japanese countries. So this standard covers all different security. I think those who worked on the display port might know this already. So we already have a basic display port standard 2.1. So whatever standard that being proposed right now for automotive is built based on top of that. So there are different levels of security, like we provide the encryption. This policy provides encryption of the data frames, the basic data that we send from ECU to displays. some encryption algorithms, some authentication algorithms being deployed. And this standard also comes with usable C model, and that basically that can be deployed from different OEM testing pipelines. So that will help us to speed up the implementation of these standards. Yeah, so these are some algorithms that we use. So for example, for security we use SPDM, and for encryption we use something called AES GMAC. These are like minor software details. Oh, yeah, so for any display in a car, so if it's more complicated, there will be a lot of topologies. Meaning, for example, this is one diagram that covers all the different topologies. So in traditional desktop, we will have only the topmost thing. We will have one ECU and one display. But in with modern cars, there are so many displays which need to communicate seamlessly without any interruption, and there are a lot of topologies that we support. So basically, any topology that automotive requires, this standard will support. Yeah, this is maybe too technical, but the idea here is there's an already DP spec or DP standard for standard implementation of display ports. So the yellow rectangle here is the one really being added. So that this was built on top of the existing DP spec. It's much easier to adapt. The only thing, if you are already an OEM manufacturer for automotives, the only thing we need to add here is this yellow block here. So these are some different profiles that we support, starting from the profile 0 is basically it's for backward compatibility, doesn't support security or safety, and profile 1 supports safety, and profile 2 and 3 will support security. So it's up to the OEM to select which part is more important to them. Based on that, they can choose the profiles. Yeah, this one just these are some algorithm that I was speaking earlier. So we have AES, DCM for encryption. So for display, we have two channels. One is the control channel. Basically, we just do the messaging from the ECU to display, and there is a data channel where we transfer all our frames. So this standard will secure both the control plane as well as the data plane. Yeah, this is the model we are talking about. So this is something we actually contributed to the standard. So we work with VESA to implement this model. This is actually a emulation or a emulation model which OEMs can use, because this standard is kind of a complex standard. It will take some time to bring that to the automotive field. So this C model or this application will help us to push the standards much faster to the automotive. Yeah, those are the things we wanted to cover. This is just a summary. Like yeah, this right now this standard is not publicly available. It's kind of proprietary specification right now. I think this VESA is working on deploying it or delivering it sometime in September. So that will be available to open world. So, yeah, those are the things I wanted to cover. Yeah, thank you.
Thank you, Karthik. So that was really technical, but again shows how much deep knowledge we have in our ecosystem. And for the last session of the day, apart from the vote of thanks that will follow it by Dr. Ashwini Agarwal, I would like to call Dr. Priyadarshini Ghosh from Horiba.
Hello everyone. I'm Dr. Priyadarshini Ghosh. I'm here from Horiba. So Horiba, with this name is known in automotive industry, of course with our emission testing. But today I'm not here for automotive testing solution. Today it's about displays, and I'm quite hearing the my previous presentations, and actually it just came in my mind that we are no longer far from. I mean, I can get my Iron Man helmet now. Maybe if you have. People have seen the Avengers series. There is a Tony Stark helmet with the transparent his screen, everything comes on it. So when I see the pictures for all the displays in the automotive last workshop, that everything is now possible. So this is the future we are going ahead, and I thank to the team that today we have people from all the different sector of the ecosystem on display, from the manufacturing, or even before me, there is a presentation from the software part that's equally important, hardware and software interfacing. And in that same aspect, when we come for the manufacturing, as a scientist, it's my job to make your work easier when it comes to manufacturing. So Horiba, as a, from that part only we work. We provide analysis and measurement tools. It's a Japanese organization, and I'll just take a couple of slides to introduce my organization. So we are into R&D, manufacturing, and sales service, analysis and measurement tools. Our head office in Kyoto, and globally we are present almost everywhere. We have 3 centers of excellence and total 28 group companies. 47 group companies. So in India, we have a small scale R&D section as well as our offices and local support throughout the country. So these are our core technologies, and in fact, in the semiconductor industry, and as well as Dr. Ashwini comes from the applied materials, the semiconductor company, we are known with our fluid control technology. Besides fluid control technology, we have spectroscopic solutions, we have pH, chemical concentration monitor, this kind of core technology we have expertise. So like I said, Horiba has 3 segments. One is the automobile, there is energy and environmental, that takes part, bio and healthcare, and materials and semiconductors. So the display as well as the semiconductor section, we are the people who, there we provide solutions. Horiba India, we started in 2006, and now we have more than 500 employees. We have more than 10,000 installations all over India, and we're quite established with our facilities. So here in New Delhi, we have our head office, and in the materials and semiconductor small scale R&D center, we have it in Pune, Chakan. The same center we also have our automotive testing solution, but like I said, today it's about displays. So these are the facilities what we have. Besides in Nagpur and Haridwar also we have facilities. Along with that, like I said, we are the analysis and measurement tool provider, which is more important to the QC analysis. And in India, if we think about from that perspective, major IITs, IISc institutes are quite doing, even we have Professor Sudhir here, is from the IIT Kanpur, they are doing the major R&D, and we just to know the R&D trends, we have built our application lab in IIT and IISc. So there we have our own instrument, and we provide service to the IIT students free of, they can come, use and utilize the facilities, and we learn from them, they learn the product from us. That's the a beautiful setup we have built over the time. Now, coming back to the solution, I know I don't want to go to too much technical, but I'll just give a brief detail because these are the topics is important. We saw in our previous presentation also that we have done a lot of advancement. We're talking about a whole rooftop HUD, and along with that 10-12 displays all around you to show you every detail of it, where your surroundings. So when it comes to these modern displays, we are seeing currently that OLED, micro OLED and LCDs are ruling. They are the commercialized. But at the same time, like Dr. Sudhi showed us that which is foldable flexible electronics, that is not anymore future. I can see this is about to be commercialized also. But this is the future trends what we are seeing. And one thing is important when we are talking about these displays, making them, so the major challenges are quality control, again supply chains and all those things are important. So when we talked about in the morning of manufacturing, making a setup here, so definitely we need to talk about building the ecosystem, and here we come. So in Horiba, we have the solution from all the way around any fab, from R&D to deposition center to, in fact, all around facility tools. The basic requirement of any fab, if we talk about it, is the water, right? And it cannot be just your drinking water or any other water which is available. It has to be ultra pure water. And there comes, we have a lot of solutions in the ultra pure water segment. Making the display or the material or AP wafer is one thing, but making sure that the quality of wafer is good, so that your product is ultimately is coming, yield is better. So in that case, the QC instrument is also important, and we have quite a bit of experimental knowledge about different QC testing setups. So what can you do with the Horiba technology? Taking example of simple TFT, starting from the cleaning, then deposition or etching process, or simply after the panel assembling and anything, maybe the thin film thickness, optical properties. If you want to measure, we have instrument for those. In fact, in the cleaning process, our chemical concentration monitors are quite popular in the worldwide industries. We have more than 60 variants, and maybe just for your information, this particular pointers. So this is an inline chemical concentration monitor, what I'm showing you. At a time, you can see 6 different type of chemicals. And if you go ahead with the offline tool of this, you can see 8 variants. So these are the advanced equipment which we provide to as an ecosystem player in the industries. Similarly, deposition, that's how we got connected with applied materials from the beginning of the time. Our vacuum solutions, as well as monitoring, as well as our fluid control technology, that's how we are known in the market. Our MFC, our CDG, residual gas analyzer, again MV2000, this is a vaporizer system. You know, many of the deposition tools Horiba has built to just to provide a customized solution to the industry, particular semiconductor industries, OEMs. So similarly in the display also they have been quite used, even in the etching process also. Now coming back, I was talking about the facility. In fact, in last one of the meeting I heard this one from a senior leader, that in India the biggest challenge is for making a fab is the water. And there I thought that yes, this is important information, and it's a really it feels very unfair, because being India is so water rich, everywhere you see water, right? So important is having an ultra pure water. Normal tap water also, you will see always a deposition of calcium, silicon, even your water cooler or water heater, always see a white color, right? And that's how you know that you need to change the filters and things. In case of fab, it becomes more challenging, because there you cannot wait to see those depositions. Before that you have to act. So an inline monitoring system is always part of the fab. And Horiba has these solutions. For example, silica monitor, there are different type of resistivity meter, different concentration solutions for that, all the kind of, to find out that what kind of maybe pH or particular concentration of that chemicals, what is there. Now, very quickly, just I wanted to show a couple of technical data with in the QC what we provide. because micro LED is a topic which we are all thinking about, right? That we will be developing micro LED, and it is although it's costly and all those things, I understand, but we are working with few of the companies in their R&D and got some beautiful data, and we are really helping in their QC with this fact that we can provide a full wafer measurement setup. Means in the micro LED, the compounds in like gallium nitride is more, or these are the material which is most used material, and here the biggest problem is their yield defects, the defects which completely destroy the material and hence the efficiency of the LED and everything. So a very simple, a non-destructive tool is Raman to find out that how is that quality of that gallium nitride. At the same time, to find out those defects are there or not, it's a PL. So we have two solutions in that range. One is this, the first one here, which can accommodate a full wafer. Here I am showing a 6-inch gallium nitride data, and this can give you a very fast full wafer map. Look at that acquisition time. It's 7 minutes, entire gallium nitride wafer. We have the photoluminescence to find out the defects in the wafer. This is a actually LED display panel, full commercially available panel, and we have shown here the PL of the entire panel. And in the bottom, actually, I have shown the high resolution PL map also. So this is distinguishing that which is the normal and the defective pixel. And just by seeing the variation in the intensity, you can actually find out which pixel is dead. And it's not only one single spot you can see. With our system, you can see the entire panel. That's the what I wanted to harp on it, that we are talking about the entire wafer characterization. Similarly, in the ellipsometer also, as we talked about TFT display, and any thin film is a part of the displays always, whether from the starting from the glass or after deposition other layers. Whenever there is a thin film, it is a requirement of non-destructively measuring the thickness as well as the optical properties. The ellipsometer is a common technique. So we have also ellipsometer, and important part is the accuracy what we can give is tremendous. For example, even in the transparent sample also. For example, the bottom data, if you can see, it's a SiO2 on a glass substrate. First of all, SiO2 on SiO2, two similar type of material. Second thing, it's on a transparent material. Still, we see a data, measurable changes in the data. And that's how you can actually identify very thin layer also with horizontal ellipsometer. So this is our value proposition. We can provide different type of multimodal measurement. We can provide high spatial resolution as well as large area measurement and the application experience. Like I showed that with the help of IIT and IIC's research, this application lab, we have built an application team which technologically help you with their expertise. So with that, I would like to conclude about our service and our involvement in the how I wanted to show you that we are there in the material characterization to process control to in the soft fab level also, lab to fab, everywhere we can be there, and we can help you with the local support with our application experience. Thank you very much.
Quick view on the analytic engineering capabilities. It's amazing. Just for reference of the people who are left, Horiba has an almost 80% market share of something called mass flow controllers that go into the semiconductor sector. And really speaking, they are the tech leaders in some of the technologies, some of the analytical engineering tools that they take to the market. So thank you, Priya. Thanks for your team for coming over.
Thank you.
And just for now. So, Bhaval, will you do the honors since you are here? Now. Thank you.